In the vast expanse of space, millions of miles from Earth, a seemingly simple scheduling error almost spelled disaster for NASA's Mars Pathfinder mission in 1997. The Pathfinder, tasked with exploring the Martian surface, suddenly went silent, leaving scientists scrambling for a solution. The culprit, a software bug that caused the spacecraft to prioritize a low-priority task over a critical one, highlighting the importance of efficient scheduling even in the most complex machines. This incident serves as a dramatic reminder that even the most sophisticated technology relies on the precise orchestration of tasks, a concept deeply rooted in the world of computer science. Just as the Pathfinder needed to manage its resources effectively, our own lives demand a similar level of scheduling and prioritization to navigate the complexities of daily life. The story of the Pathfinder may seem like a distant anecdote, but it holds valuable lessons for anyone who has ever felt overwhelmed by a to-do list or struggled to manage their time effectively. By understanding the principles of scheduling used in computer science, we can gain insights into how to optimize our own productivity and avoid falling prey to the pitfalls of poor time management. At the heart of every computer lies an operating system, a silent conductor orchestrating a symphony of tasks, from running applications to managing memory. A key component of this orchestration is the scheduler, a software component responsible for deciding which task gets executed when and for how long. This process of prioritization ensures that the computer runs smoothly, allocating its resources efficiently to meet the demands of various programs and user actions. Think of your own brain as a sophisticated operating system constantly bombarded with inputs and demands. Every decision you make, every task you undertake, represents a process vying for your attention and cognitive resources. Just as a computer relies on a scheduler to manage its workload, we too employ mental scheduling mechanisms to prioritize tasks, allocate our time, and navigate the complexities of our daily lives. However, our internal schedulers, unlike their digital counterparts, are often susceptible to biases and inefficiencies. We may prioritize tasks based on urgency rather than importance, allowing ourselves to be pulled in multiple directions by the constant influx of emails, notifications, and demands on our attention. This is where understanding the principles of computer scheduling can offer valuable insights into how we can improve our own time management strategies. While prioritizing tasks is crucial, spending too much time on prioritization itself can become counterproductive. Imagine spending hours meticulously organizing your email inbox, creating elaborate folder systems and color-coded labels, only to find that you've made little progress on actually responding to emails or tackling your actual work. This phenomenon, known as over-prioritizing, can trap us in a cycle of planning and organizing without making significant headway on our actual goals. In computer science, this problem is akin to using a quadratic algorithm, where the time spent on a task increases exponentially with the number of items involved. Just as a computer can become bogged down by an overly complex sorting algorithm, our brains can become overwhelmed by the sheer volume of decisions involved in excessive prioritization. The key to efficient time management lies in finding a balance between planning and action, prioritizing effectively without getting lost in the minutiae of organization. By recognizing the pitfalls of over-prioritizing, we can free up valuable time and mental energy to focus on what truly matters, completing tasks and achieving our goals. Section 4. A kernel of wisdom. The Linux solution. In 2003, the developers of the Linux kernel, the core of the Linux operating system, faced a scheduling challenge that mirrored the problem of over-prioritizing. The existing scheduling system, while theoretically sound, became bogged down as the number of tasks and their priority levels increased, leading to performance issues. Their solution? A radical simplification of the priority system. Instead of relying on a complex hierarchy of priority levels, they implemented a limited number of priority buckets, grouping tasks with similar urgency levels. This streamlined approach significantly reduced the overhead associated with scheduling, leading to a more efficient and responsive system. The lesson here is that sometimes simplification can be the key to greater efficiency. This principle translates directly to personal time management. Rather than attempting to meticulously prioritize every single task on our to-do list, we can benefit from grouping similar tasks together and allocating specific time blocks for their completion. This approach allows us to focus our attention and energy, minimizing the mental overhead associated with constantly switching between disparate tasks.